So we have ray BA or directed line segment BA. So the initial is B and terminal is A, and we have point C in extension of BA ray. So we have the origin point O to B will be R1 and be represented by X1 and Y1, and we have from O to A will be R2 represented by X2, Y2, and from O to C represented by R, which is X and Y. So we have from point B to point C, from the initial to the point C, point of division C, will be M2, the ratio M2, and from point of division to the terminal will be M1. So we have C belong to the straight line AB, but C not belong to BA line segment. Then C divides AB externally by the ratio M2 to M1. So M2 over M1 will be less than 0. It means will be with negative sign or negative quantity. Then one of the two values of M1 or M2 is positive and the other is negative. So we have here C is the midpoint of AB, where A X1 and Y1, and we have B X2 and Y2. M1 equal M2 equals M, because C is midpoint. So we have R, vector R, which is represented by OC, which is represented by ordered pair X and Y. It means R1 plus R2 divided by 2. This is vector form, and Cartesian form will be X1 plus X2 ordered pair X1 plus X2 over 2, and Y1 plus Y2 over 2. This is Cartesian form. As we said before, this for in Prep 3. So we have an example: A 2 and negative 1, B negative 3 and 4. Find the coordinates of the point C, which divides AB internally by the ratio 3 to 2 in the vector form. So it's important to know the initial point and the terminal point. So we start with A, because AB directed line segment, its initial is A and its end point is B. So we have A2 and negative 1, and we have B negative 3 and 4, and we have the point C, X and Y, and C divides AB internally, so C belongs to AB line segment with ratio 3 to 2. So we have from the point of the starting point, which is A, will be 3, and from C to B will be 2, and from A to point of division will be M2, from point of division to end point will be M1, and we have M2 to M1 will be 3 to 2, and it will be positive quantity. It means more than 0, because C divides A, B internally. So we have R, the rule in vector form. If we want to find C in vector form, R equal M1 R1 plus M2 R2 over M1 plus M2. So M1 will be 2 multiplied by R1, which is represented by the point A, 2 and the negative 1, plus M2 will be 3 multiplied by R2, which is represented by negative ordered pair negative 3 and 4, over M1 plus M2, which will be 2 plus 3. So 2 times the ordered pair 2 and the negative 1 will be will be 4 and negative 2, and 3 multiplied negative 3 will be negative 9, and 3 by 4 equals 12. So we can make the addition between the two ordered pairs. Over 2 plus 3 will be 5, so negative 5 and 10 over 5 which will equal -1 and 2. So the coordinate of the point C will be -1 and 2. Also, we can use the Cartesian form to find the coordinate of the point C. By Cartesian form, we can use the rule x and y, which represented the point C, equal m1 x1 plus m2 x2 over m1 plus m2 and m1 y1 plus m2 y2 over m1 plus m2. And we have the point A represented by x1 and y1, and we have the point B represented by x2 and y2, and we have m1 will be 2 and m3 will be 3. So we have substitution by the values of m1 will be 2 multiply x1 2 plus m2 will be 3 multiplied by x2 will be -3 over m1 plus m2, which 2 plus 3, and 2 times y1, which is -1 plus 3 multiply y2, which is 4 over m1 plus m2, which is 2 plus 3, which is equal to -1 and 2 also. So we have here a 2 and 0, b 1 and -1. Find the coordinate of C, which divides AB externally by the ratio 5 to 4. So we can draw the directed line segment AB. Its start A and its end point B, or terminal point is B. So we have A 2 and 0 and B 1 and -1, and we have the point C, the point of division in the direction of AB, and C equal ordered pair x and y, and we have the ratio m2 to m1 will be 5 to 4, so m2 represented by 5 and m1 represented by 4, and 5 from start to the point of division, then from point of division to the end, so 5 to 4. So m2 to m1 5 to 4, and we have negative sign with 4 or with 5. You can write the negative sign with the scalar m2 or with m1 or with ratio m1. So 5 to -4 because the division is externally. And we have r1, which is represented by 2 and 0, and we have r2 represented by 1 and -1. So we can take m1 equal -4 and m2 equal 5, and r equal m1 r1 plus m2 r2 over m1 plus m2, and m1 will be -4 multiply r1, which is 2 and 0, plus m2, which 1 and -1 multiply by m2, which is 5, over -4 plus 5, so will be -8 plus 5 over 1, which will be -8 plus 5, and 0 minus 5 over 1 will be -3 and -5. This represents the coordinate of the point C. So C will be -3 and 5 and -5. And also we can use Cartesian form to get the coordinate of the point C. The point of intersection of the medians of triangle. We have here ABC is triangle, and we have the point of intersection of the medians of triangle, which is the point M, and we said before this point is called point of concurrence, and the point of concurrence divide the median with ratio 2 to 1 from the vertex, or 1 to 2 from the base. So we have a x1 and y1, b x2 and y2, and c x3 and y3. So D is the midpoint of BC. So we can find D with the rule x2 and y2 plus x3 and y3 over 2. So D will be x2 plus x3 and y2 plus y3 all over 2. So we have D x2 plus x3 over 2, y2 plus y3 over 2. So we can find the point M, and the point M divides the line AD internally. So we can use the ratio 1 time x1, the ordered pair x1 and y1, and to multiply the ordered pair of the point D, which is x2 plus x3 over 2 and y2 plus y3 over 2, all over 3. all